Okay, this problem is going to demonstrate pretty much all the properties of logs that you have to worry about. And you don't have to worry because it's super simple. It looks funky as you do it, but it'll make sense as we do it. So if I'm solving for x as an exponent, you know I got to log both sides. So I'm going to do that. I'm going to log both sides. And what comes out, you know the exponent goes in front of the log. And 7 stays there. And now this is the exponent, so this is going to go in front of the log. This whole unit, okay? And then 13, okay? So I'm looking for x. X is there and there. I want x on its own on one side of the equation. So what I can do, first I would think, oh, I'll just divide the log and divide over there. But then I have x minus 4 over here, and then the x is over there, and it's all these logs all over the place. It's just crazy. So to make it easier on myself, one property of logs that we can do is the distributive property, which means I can take this x, connect it to that, and then take this negative 4 and connect it to that separately, and it'll still be the same. So I'm saying it differently, and it makes it a lot easier, and you'll see. So I'm distributing, and then the negative 4 log 13 equals x log 7. So you see what I did there? Anytime you see that, please put it in this form because they're probably want to make sure you know how to do that. So that's the distributive property of logs. Now, what can I do next to find x? Well, let's get x on one side. So let me bring that over here. I do that by subtracting x. Log 13 cancels out, and I'm left with negative 4 log 13 equals x log 7 minus, because I'm subtracting, log 13. Okay, so, sorry for my handwriting. So I got x log 7 minus x log 13. They're not like terms, but here's the third property of logs that we can do. You know how we distributed over here? Well, I can do the opposite, the reverse, and factor this x out. So if I pull the x out of here and pull the x out of here, I'm left with x times log 7 minus log 13. Look at that. So I got x on its own. So and you see, it almost looks the same as that. So see, you got the x minus 4 in parentheses, but now we got the logs in parentheses. So it's perfectly acceptable. It's another way of saying the same thing. And it makes it a lot easier on us because look at this. We got negative 4 log 13. To get x on its own, this is its one unit. I can just divide by this entire unit. 13. Bye-bye. And then just divide it over here. And it looks funky, but if you plug it in your calculator, you know, carefully, you already have x. X equals negative 4 log 13 over log 7 minus log 13. So that's how we went from here to there. Feel free to rewind this video so you know, but make sure you remember the distributive property and I don't know what to call this, but I guess the reverse distributive property or the factor out property. And just recognize that this is one unit, so I can cancel it out just like as if I was canceling out, you know, a 2 here. Boom, it's one thing. I'm left with x. You know that. It's just the same property, just we got a lot more going on. It's still one unit.